of that. And I'll be meeting with a few students today if you want to go over some of the, I think we'll mostly go over the level 1 questions. So we're going to do 2 things today. Most of this week, today, tomorrow, and Thursday, we will be doing some activities. Some of it will be kind of free time for you to just work on your own. But for the most part, we're going to be doing a couple of different activities. So first one is the constant velocity lab. This is going to be a pretty short lab. It's basically going to be done all in class. Hopefully it won't be any homework for you. And then we still have to finish the inattention part 2, and we'll do that on Thursday. And I think that you'll be able to finish everything on Thursday because I'm going to give you the whole period on Thursday to work on that. I'll answer whatever questions you have. That leaves Friday, where we are not assessing on Friday. I know the assignment list says we're assessing on Friday, but we're not assessing on Friday. We're going to assess after the weekend, so that's the following Tuesday. So that's 4 more days for you to practice and review. But on Friday, you want to have all your questions ready. So if there's anything you didn't understand from your last assessment or you look at it in a worksheet, I have the whole day. I have nothing else to do except to talk to you individually or in small groups. So just be getting prepared for that, be reviewing. I'm sorry I haven't got your test scored yet. I'm about halfway through it, but I will finish that after I have my meeting after school. And I would say I would think by 7 or 7:30, you'll have your scores back. I'll send you the work with the comments. And I would really appreciate it if you read the comments, and let's say I made a comment about something that you did wrong, and you feel like you understand it, click the resolve button. Click the resolve button. It sends me an email. It's awesome. That's really great. I really appreciate getting that kind of feedback. Or maybe you have a question. Maybe you read my comments and you don't understand what I'm saying. That's even better. No, yes, I'm going to change the date. I'm so sorry for that. I apologize. Yes, I will change the date. You can actually go back in. You should be able to resubmit if you want to add more to it. Yes, I expected that we would talk about it today, but we're just a little backed up. So everybody is like, we're just shifting everything back just a little bit. Yes, inattention is not due today, and I'll make an announcement in Google Classroom. I'm going to push it back to Friday. So Friday by midnight. So as long as it's done by Friday by midnight, no worries, and we'll work on it on Thursday. So I will take care of that part. Yes, thank you for asking about that. So the first thing that I wanted to do with you guys is let me go to your quiz. See if I can find it here. So what I'm going to look at is I want to look at measuring with precision because it was clear a lot of people really struggled with that. I could see a lot of anxiety about people felt like they were giving good answers and they were being marked incorrectly. So let me go over that with you guys. I'm going to bring up your test, and then I'm going to share it with you. Oops, wrong place. Measuring with precision, 7th period. All right. All right, so I've got the questions up here. Let me go and share with you. Home tab. Okay, if I can get all your cameras on, because I do actually have you guys on separate screens so I can see your faces, and I am really looking for recognition, or I'm looking for you to something to indicate to me that you are understanding what I'm saying or you don't understand what I'm saying. So if you guys can all bring your cameras on. I would like to ask today if I could get thumbs up once in a while on things that I'm asking you. And if you can kind of tilt the camera so I can at least see that you're there, that you're present there. And if you have any questions, turn your mic on and stop me. You're never interrupting me. You are never interrupting me. Just turn your mic on. If you have a question, I want to stop and address it. If it's something that I need to address with you personally, then I'll just let you know, hey, we'll meet after school or after class. But please turn your mics on. If you see I'm not responding to the chat, somebody turn your mic on. Let me know there's a question in the chat. All right, so I think that part of the disconnect with the measuring with precision quiz is that some people didn't really understand what I was asking you to do. I am not just asking you to read the device. I want you to read it to the highest level of precision that is possible for that particular device. And what that means is the smallest unit you can measure. That's what determines your precision. So let me give you an example. Here is a meter stick with no marks on it. That is not precise. There are no markings on it. Here is a meter stick with a marking every 10 centimeters. That's better. That's better. It's more precision. I also have another version where it's marked with every 100 marks. That's even better. And watch the last one. Look how good this is. 1,000 markings on this meter stick. So this meter stick has been divided into 1,000 parts, and I can read them so easily. That's going to allow me to make a very precise measurement. But if I use this one, how am I going to measure? It's going to be very difficult. It has very low precision. I could measure total meters. That would be easy. But if I try to get down below a meter, it's going to be pretty hard for me to do because this lacks the precision. So in any measurement that you make, you want to make sure you record the highest level of precision that you can get, and that will require you to estimate only the last digit. Not 2 digits, not 3 for sure. The last digit will be estimated. And because it's estimated, I will give a range of answers. So my answer is not perfect. My answer is no more better of an estimate than yours is. But I do feel like based on the location of the marker, some answers don't seem as fair as others. So let me show you this first one. And I think like maybe I made a mistake in the sense that I shouldn't have given this problem first. I should have made this letter, maybe letter Z or something like that, because this is the hardest question is right off the bat. And I'm sure that probably, you know, in your mind, it kind of puts you in a bad state of mind because you're right away off the bat. You're like, I don't really know for sure what to do with this. I'm going to read the markers. Look at this one my cursor is pointing at. I am pointing at 10.5. I'm not estimating that that's 10.5. That line is 10.5. Can you guys can I get more cameras on? Because I can't really do the thumbs up thing if nobody has their camera on. Could I get a thumbs up? You guys, you can see what I'm talking about. I'm pointing at the 10.5 line, and that line is exactly 10.5. It's not approximately 10.5. It is exactly 10.5. Okay? These lines allow me to read one place after the decimal. So here I go. I'm at 10.5, 10.6, 10.7, 10.8, 10.9, 11. No, that doesn't fit the pattern. The pattern was one place after the decimal. So look, I don't make the rulers. If I made this ruler, I would have said this was 11.0 because that is what that line represents. It does not just represent 11. It represents 11.0. Look, I'm going to count it off again. 10.8, 10.9, 11.0, 11.1, 11.2. You see how the pattern continues. So this is 11.0 with no estimation at all. The next digit is the estimated one. So here's the answers I accepted. I took 11.00. That's the correct level of precision for this device. Every measurement on this ruler, you should be able to make to 2 places after the decimal. So I said, I think it's 11.00, but I took 10.99. I also took 11.01. So maybe you say it's a little before, a little after. That's fair. That's fair enough. I can see how you could see that. But if you said 11 or 11.0, that's just incorrect. You have not recorded the highest level of precision for that device. You read it, but you didn't record the highest level of precision for that device. That's what you're being asked to do. I feel like reading it, if I was just asking you to read this, I would have asked you to do this in like 3rd grade. Hey, what's the value? Oh, 11. This is 12 point something. But now we're asking you to go to that next level to make sure that you extract everything from this device that you can, but you don't put more or less. So let's move on to the second one. I'll pause at the end of the rulers in case anybody has a question. Let me show you the answers I accepted for this one. So you can see it's a little bit past 12.2. So I accepted 12.21, 2.2, and 2.3. I mean, maybe I could take 2.4, but I mean, to me, when I look at that, there's no way that last digit is a 4. I would say the 2 is the best one, 12.22. That's probably it. But I think these other answers are good. Those are reasonable answers. But you needed to record to 2 places after decimal again. The last question for the rulers is Z. You can see that Z is between 14.0 and 14.1. So my answer is going to be 14.0 something. And so I used these answers. I said it was very close to the middle. So I took 0.04, 0.05, 0.06, and 0.07. That's a pretty wide range of answers. If you look at that closely, I'm sure you'll agree one of those answers is the measurement for that. And so I gave kind of a range of possible answers. But notice, 2 places after the decimal. If I can make one measurement to 2 places after the decimal, I can make every measurement to 2 places after the decimal. So maybe if I had put X last, then maybe it would have clicked in your mind, like, oh, I know I have to give more digits, because all of my answers for this should end at the same decimal place. Are there any questions about the ruler so far, or anything you want me to show you again? Can't even see half of you. Thank you, Jamal. Jamal is class spokesperson, so if you don't say something before he does, then we're moving on. I feel like this is very consistent. So it's 2 places after decimal. Let me show you an example where it's not consistent like that. Let's look at these 2 graduated cylinders. So as I told you before we started this assessment, you really need to make sure, what do the unmarked lines represent? What do the unmarked lines represent? What position are they in the number? Are they in the ones position? Is that in the tens? Is it in the tenths? If you look at this one, this is just like the ruler. The markings are whole integer values, and then the markings in between are the first place after the decimal. So here is 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, and then it's a little past 2.6. So here's the answers that I accepted. 2.64, 2.65, and 2.66. In the next test, I will stretch that out a little bit further. I'll go all the way down to 2.63, and I'll go all the way up to 2.67. But just so you guys understand, you won't see this picture again. You'll never see this picture again, because I'm never going to use this picture again. It will be a new picture, and you will have to evaluate that picture to see what do the unmarked lines represent. The unmarked lines here represent that first position after the decimal. So I have to estimate one more, and I'll give you a wide range, but you have to estimate the right number. You have to estimate that last digit. So this was just like the rulers. I got 2 places after the decimal, but look at the next one. If you look at this, the individual markings are not marked are not the 10th position anymore. Now they're the ones position. So look, this is 20, 21, 22, 23, 24, 25. So now I will not be able to record as many places after the decimal because none of the markings on this graduated cylinder represent any of the places after the decimal. The markings on the cylinder represent the ones position and the tens position, and that's it. So I said that this was pretty close to the middle, but I thought it was a little bit on the low side. Again, I will give a much wider range of answers on the next question because I feel like I can see that you could maybe say 21.2 or maybe even 21.6. I think those are fair answers, and I will give you a little bit wider margin of error so that as long as you give me the right number of places, your answer is going to be there. You will get credit for that answer. But these two graduated cylinders are different. This graduated cylinder has less precision because I cannot record as fine a detail as I could with the other one. When we get to the third one, then we go back to the same thing we were before. Now I can get 2 places after the decimal because the unmarked lines represent the first place after the decimal. So this is 6.6, and the question is, what's the next digit? I said that it's right on the line, so I said 60, but if you said 61 or 6.59, that's fair enough also. I might even stretch that out a little bit to give you more options of answers that you could give for that one. But remember, when it's on a line, when it finishes exactly on a line, that means your last digit is going to be a 0. If you believe that it's really on the line, then you're going to make your last digit a 0. All right, with the thermometers, I did the same thing. Here is one which is marked in tenths. So this is 36.1, 0.2, 0.3, 0.5, 0.6. And so the answer that I was looking for that was either 36.63 or 36.64. As I said, I will make a wider range of answers. So I'll go down to 6.2 and maybe up to 6.6. I think those are all fair. To me, it's below the midpoint, but you might have seen it a little bit differently, and that's fine. My answer is not perfect. I'm estimating. And estimation is by definition not perfect. So I will give a pretty good wide range. Yes.
So like, how do we know? Okay, so you know how in some answers you only put one place value and then in other ones 2 of them? Like, how do we know which ones do we only put 1 value or like 2?
There's always going to be, so you have what you're reading, and then you have the last digit is estimated. So if you look at what I can read, the 36 I can read, right? We all agree on that?
Yeah.
Okay, the 36.6, I say that I'm reading that also. This line right here, that line represents the 0.6 part. So I have not estimated anything yet, but now I've reached the limits of what I can do with the lines, right? There's no more finer lines to look at. There's not like little tiny lines in here. So now I've reached the limit of what I can get, and I'm already at 36.6. So now all you need to supply after you've read it is, what is that next digit? And so it's going to be one more digit after the part that you finished reading. So for this one, 36.6 I read, that means I need to supply one more digit. And as I said, you know, it seems like the best thing to do is to ask yourself this question: is it at the midpoint or not? I said it was below the midpoint, but maybe you say it is at the midpoint. If you say it's at the midpoint, then you would say 36.65. That last digit would be a 5. But the 36.6, I'm not guessing. That is definitely 36.6. There's no question. That is 36.6. The question is, what's that next digit? It's just that one more digit that you need to give. Does that make sense?
Yeah. Thank you.
Now, let me point out one thing. Let me go back to this guy, because I saw with this one, some people said 21.30, and they kind of were arguing that, no, that's right. It's not right. So let me explain why that's not right. Remember, each of these lines represents the ones position. So what I'm saying is, I think that as a human being, you can look between those 2 little teeny lines between the 21 and the 22, and you can break it up into 10 parts, and you can tell me which of the 10 parts is it. But when you add one more digit, so now let's say you said this was 21.30, what you're saying, just think about this for a second, what you're saying is you took the space between 21 and 22, and you divided it into 100 parts, and you can tell me which part it is? No way in hell you could do that. There's no way you could take that little teeny gap and in your eyes separate it into 100 parts and tell me which of the 100 parts is it. So to give me 2 digits, 2 estimated digits, that's crazy town. That's crazy town. You can't, you're making it up. There's no way you could have seen that. Now, you might have thought you saw it, but you could not have seen it because nobody is that good. So that error is just as bad as giving too few digits. Too few digits is you not recording the quality of your measurement, which is that you're underselling yourself. But when you give too many digits, it's like you're lying, because you're saying that I have measured this down to 2 places after the decimal when that is impossible to do with this device. So that's why we're trying to get to the adult level. Not just can you read the device, but can you extract everything that is possible to be extracted from this measurement, so that when we move forward, we have the best quality measurement that we can possibly make with this device. Let me go through the last one real quick here. So that was, again, I took 0.63 and 0.64, but actually people complained and they said 0.65, and I agreed with them. I think that probably was right. I don't need to go back and change all the tests because every person whose test I change is going to do a retake anyways. So why don't we just wait for the retake and you'll just take care of it then. I don't need to go back and fix anybody's quizzes because there's no point in working for 1 point. I want you to get an 8 or a 9 or a 10 on this quiz, not a 5 or a 6. So I think hopefully next time it's going to go a little bit easier. It'll make more sense to you. So look what I can read. 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, I'm reading that. I'm not guessing. That is 18. The question is, what's the next digit? That's going to be the first place after the decimal. And I accepted 18.8 and 18.9. So notice only one place after the decimal because the unmarked lines are the ones position. So I can't read any places after the decimal. I can only estimate that first place after the decimal. Any questions so far? Any one of them you wanted me to go over again? Did you want to look at?
So we're going to retake the whole test, right? Or like, do we have to just retake it if we want to?
Oh, it's just if you want to. Yeah, if you had a good grade, like if you had an 8 or 9 or a 10, I don't really see why you need to do it. That's a very good score. It's a small grade overall. But if you had below a 7 and you understand better what I'm explaining now, what's the harm in doing a retake? And the skills retakes I will allow you to do in class. The velocity retakes and the concept retakes, I don't want to do. They're much longer and it's like too hard for me to watch what's going on. But on Friday, I will have a retake for conversions, I'll have a retake for scientific notation, and also one for measuring with precision. And in the second half of the class, you could take, you could take all 3 of them if you wanted to. I think the conversions takes a little longer, so I don't know you would want to do that. But if you wanted to knock out scientific notation and measuring with precision, great. Let's do it in class. I'll rescore it for you. I'll replace your grade. And if you get the grade you want, then you don't have to think about it anymore. Now, I'm not saying you don't have to think about it. Like we're going to still talk about this, but I won't test you on it. Once you've proven you understand it, I'll stop testing you on that. So yeah, it's not a requirement. You don't have to redo it, but I hope a lot of you will because I know you can improve. I know you can do better than you did. Okay, are there any other questions before we move on to the next step? We're going to be talking about, let me get rid of this presentation for a second. So we're going to be doing what would be the constant velocity lab. Now, normally with the constant velocity lab, what would happen is we would spend like 4 days. We'd collect data on 1 or 2 days, and then we'd go to the computer lab. It would take like 4 or 5 days, and you would be asked to write the entire lab report. We're going to do things differently this year, partially because of the fact that we're remote, and then also I think maybe that wasn't a good way to do things. I'm like reflecting myself always as a teacher. I think maybe it's too early, even though in theory you should have written lab reports as a sophomore in chemistry. Let's assume that we're going to focus on the individual sections of the lab report. So for these first couple labs, we're just concerned about the data. Let's just make sure everyone feels confident that they can make the data table, and that if there's a graph required, that you know how to make the graph. Now today, I don't think we'll have enough time to get to the graphing part of it, but we will get to the data table portion of it. And so what's going to happen with a lot of the labs is I'm going to go into school and I'm going to videotape the lab. So I'm going to have me and maybe 1 or 2 other teachers, and we'll videotape everything so that you can actually still make the measurements and you can see how the experiment was set up. And so I'm going to show you that video in just a moment of how the experiment was set up. But before I do that, I want to introduce you to this new way of thinking about things. I have no lecture video on this. There's no video on this. I'm recording this one right now so that I can post this in case people wanted to go back and look at it. But I would suggest maybe you do want to jot down a few notes on this topic. It's very short. It won't even be a half a page of notes, but it might be worthwhile to jot down those notes. This thing is called the dot model, D-O-T, dot model. Let me try to pull you guys a little closer. I know it's hard for you to see that whiteboard. I really apologize. I'll try to get better markers that make a little bit thicker lines. But this dot model is a very fascinating thing because you can apply math to it. It's not like math doesn't work, but it also, when I ask you questions on the exam, I won't be putting any math on it. I'll simply be asking you to look at the model to establish what was happening to this object. So let's assume for argument's sake that my heart, my physical heart inside my body, is creating little dots in space. Every 1 second, my heart is going to make a little dot at its exact location. And that little dot will represent me. So when I stand in place, like I am right now, my heart just keeps putting those dots down in the same place. So in 3-dimensional space, here inside this little space that I'm in, little dots are being put by my heart. So we're just imagining this. And what is going to happen is when I start to move, I'm going to start to see a trail of dots. So right now, that little dot is being left in the same place over and over and over and over and over and over again. So it's starting to get very dark. representing that I was there for a long time because I was in one place for a long time. But as I start to move, what you would see is a little trail of dots representing where my heart was every second of motion. And that's a really powerful thing. You'd be surprised. That seems like maybe that's really simple, but no, there's so much information you can get from that. And you can actually make measurements from the dots. I can take a ruler, I can pick up my ruler right here and start measuring the distance between the dots. And I can figure out a ton about my motion. In fact, I can almost figure out everything about my motion from the dot model. So the basic idea behind the dot model is in some unit of time, some period of time, we're going to leave a dot that represents the object. Now, obviously, my heart doesn't represent every part of my body. It doesn't represent my head and my arms. My arms, my heads are in different places. But I'm going to use that dot where my heart was to represent where was my body overall. And that dot can be used to represent a car. You could represent the Earth. We could have a star. We could have a whole galaxy. We could have an atom. We could have a molecule. We could have a little particle of sand, and we could watch the little particle of sand as it moves along the beach and make a little dot model of the particle of the sand. So instead of looking at the whole thing, like I'm not going to look at my whole body, I'm going to pick one thing that represents my body, and I'm going to watch it as it moves through three-dimensional space. So here's what would happen if we did this, and I were to make the dot model. So let's assume, by the way, if I ever use a color of marker that you have trouble seeing, I try to avoid the red one because I know red-green color blindness is pretty common. And sometimes people can't see the red at all. It just looks white to them. So if I'm using a color or it's just not easy to see, please turn your mic on and tell me. Let's look at what would happen first. So as I stand here, not perfectly still, but pretty still, what I would see is that the little dot keeps getting put in the same place over and over and over and over again. But now I'm going to start to move. Now I'm going to start to move. Let's watch what happens. In the beginning, the dots would be very close to each other, which would indicate that I was moving very slowly. Remember, each of these dots represents an equal time interval. Each dot represents some interval of time, and I'll talk to you about that interval when we get to the lab. But what it tells me going from these two dots to these two dots is that I sped up. And does this make sense? Can you guys give me a thumbs up or thumbs down? The bigger the spacing, the faster I was moving. Remember, each dot represents some unit of time. So these are all equal intervals of time, so that's a fair comparison. And I'm saying that if the space is bigger, that represents a faster speed. Now, I can't speed up forever. So at some point, I need to just steady out at a steady pace. Here's what that looks like. So this is acceleration. So that's what acceleration will look like. What does constant speed look like? So what you're going to see with constant velocity or constant speed is you're going to see that the spacing is equal. I'm trying to give you the vocabulary you're going to want to talk about if you see this problem. How would you know where the constant velocity part is? You'd look for even spacing. Nice, evenly spaced dots showing that it travels the same distance in each interval of time. It always travels the same distance in each interval of time. Then I would say constant velocity. And here's how it would look. Constant velocity. One last thing to look at. What happens if I slow down? If I slow down, so if I slow down, then I'll see that the spacing was originally very large, but then as time went on, in each interval, the gap got smaller, smaller, smaller. That's me slowing down. I'm going less and less distance in each interval of time. So this is called slowing down. Or if you want a fancier word, it's called deceleration. Deceleration is the opposite of acceleration. Acceleration means to increase your speed or velocity. Deceleration means to reduce your speed or your velocity. So we'll see all of these in the lab that we're going to do. But this is the basic idea behind the dot model. And now we're going to look at a machine. So I actually have a machine that will create a dot model for any object. You can connect this machine to any object, and it will create a dot model of their motion. But instead of leaving the dots every 1 second, it puts the dots down much, much more rapidly. So what we're going to do right now is, if you can all, while I'm getting ready, could you please go to Google Classroom? And you'll see that there is a laboratory assignment that I just posted. Can you click on the Google Sheet and just get it open so that we're ready to go when it comes time for us to start working on that sheet? And I'll start getting everything left. All right, I'm gonna move you guys over here. And let me go to, I'm gonna present, and I'm gonna show you your classroom in Google Classroom. Okay, so here we are in Google Classroom. I click on classwork. I don't know why this is up here at the top. I'll move it. It should be down at the bottom. Huh. There's actually two categories that say lab investigation. But there's only one in there now. So constant velocity lab, I'm going to click on that, and I'm going to read the first part. In this lab, you will watch a video showing how the data was collected, and you will be able to make measurements from the video for displacement and velocity. Your table should have the following column headings: time, displacement, two-dot distance, and velocity. Can we get a jump on this right now? And I'm going to stop for 2 minutes while you add those. And I just want to make it clear. Let me get rid of this. Oh, brutal. I'll have to clean that up later. So the categories are going to be time will be measured in seconds. Okay, time will be measured in seconds. And displacement will be in centimeters. Okay, we have to have these two columns today in order for you to continue with the activity. Now, if you don't fill in the other two columns, two-dot distance and velocity, if you don't add those, it's no big worries to me today, but I need these two columns to be in there, and I would like to have the correct units. Okay, so if you can, while I'm getting everything ready, if you could go ahead and put those column headings on your Google Sheets, then when we get time to do the activity, you'll already be ready to go, and you can start putting the numbers in. Okay, let me get the videos loaded. I'm gonna go to my playlist. Let me back up one. Okay, let me stop sharing for just a second so everybody can see more clearly. Okay, so again, somewhere on that table near the upper left-hand corner, put in time in second, and put displacement in centimeters, and then look in Google Classroom. It tells you what the next two columns are. You can add those in now, or we can do it later. You can do it tomorrow if you want to. Yes, Ariana, it was the thing that was posted this morning. That's right. So that's the activity we're going to be doing. I'm going to walk you through it. So I'm not going to leave you on your own. We'll work on it together, and we'll collect the data together. So I'm going to play a short 4-minute video. It explains how the device is called the ticker timer. Sorry, let me move this a little bit. The device is called the ticker timer, and it's a machine that literally creates a dot model for any object. So I'm looking at, when you click on the playlist in the assignment, it's going to take you to this screen. Let me show you. Nope, not that one. Let's do this one. It's going to take you to this page where you will see 4 parts to the videos. I've already done part 1, the dot model. You only need to look at that. If you felt like it was confusing, you could look at it again. We're going to watch the ticker timer. And then when I get to the part on data collection, I'm not even going to play the video. I'm just going to slide through, and I'm going to show you how to make the measurements that we need to make. And then that'll be the end of it for today. And then tomorrow we'll look at the data collection for the other graph that we're going to look at. Let me get rid of this guy. All right, so here we go. If the volume is bad, some people were saying that the volume wasn't great. Let's try to make sure everything is up all the way. All right, let me go full screen. All right, guys, here we go. Just paying attention. You don't have to record anything. There's no notes or anything like that. Just listen to how the machine works. Okay, so now we're going to talk about this machine called the ticker timer. And this machine can create a dot model by allowing you to connect a piece of paper that's going to run through these 2 guides over here, the 2 silver guides. And as the paper gets pulled through, this little metal arm is going to leave a little series of dots. I'm going to explain to you how the thing works. Now, it's not really that important because we're not going to ask you to write about it. It's not really an issue right now. The reason why I'm going to explain to you how it works, though, is because it is really important in any investigation or any kind of discussion that we understand how the equipment works, we understand what the limitations of the equipment is, and we understand like what the strengths of the equipment is. So I'm going to explain to you how the machine works, even though you won't ever be tested on it, and you're not going to be asked to repeat this. But you do want to be thinking about, how is this thing making its measurements? How accurate is it? Is it valid to make the measurements in this way? So the way this device works is there's an electrical cable. So this is plugged in right now. I have it plugged in. If I were to turn it on, you'll hear it start to vibrate. Okay, and what it does is it takes advantage of our electrical system. So in the United States, we have an electrical system in which the current switches directions. So sometimes the current's going this way, and sometimes the current's going this way, and they keep making the current go back and forth. And it turns out they make it go back and forth 60 times every second. So that is really fast. So the electricity is going backwards and forwards very quickly inside of our electrical lines. And because this is connected to that electrical line, this small electromagnet that's connected underneath this metal tab right here begins to create a magnetic field that either pushes or pulls. So this little metal arm can move up or move down, and it's pulled or pushed by the electromagnet that's underneath it. So what's going to happen when I turn it on is the little metal arm is going to start to vibrate, and it vibrates at an incredibly precise tempo. So it's going to go off 60 times every second, or that is to say that the little arm will come down and hit that little hit the little block one time every 1/60th of a second. Now that's not going to leave the marks because of course we have to have something that's going to be able to leave the marks on the piece of paper. So this little circular piece over here that I'm spinning around is called a piece of carbon paper. So the carbon paper has essentially the same kind of thing that your pencil has on one side of it. On the other side is just kind of regular paper. It's facing towards the block right now. And what I'm going to eventually do is use this piece of paper. So I have long, long rolls of this paper. I have hundreds of meters of this piece of paper. And we're going to slide that piece of paper. I'm going to bring it a little bit closer so you can see more clearly. There are two guides. So these two guides are going to help keep the paper so it slides straight through the ticker timer. So we make sure that it's on the right part. And so if I slide that under, and then now what I want to do is go under that piece of carbon paper. And then I'll feed it through the other guide on the other side. Okay, so now I've got the piece of paper through there. The little piece of carbon paper is going to spin as the piece of paper pulls through, and this makes sure that we have a nice fresh piece of carbon paper so the dots don't fade out. Otherwise, if it just keeps hitting that carbon paper in the same spot, of course the carbon paper will wear out and it will no longer leave dots. So I'm going to show you just a sample of what the data looks like. I'm going to hold it really close to the camera. I'm going to go ahead and turn on the ticker timer right now, and let me show you what the dots look like. All right, so here we go, taking a look. I'm going to try to hold it really close so you can see very clearly. So there's the beginning of it, is right here, this big blob of dots that you can see. And you can see as the car begins to, as I begin to pull, it's starting to speed up. So I see the dots are getting more and more widely spaced, and I see a long series of dots on this piece of paper. This just created a dot model of the motion of my hand, and I can go back now and start making measurements from this piece of paper. That's what we're going to do in the constant velocity lab. So now you know how the equipment works. You have the basic premise of it. We'll explain a little bit more how we're going to manage the data when we get to the constant velocity video. Okay, again, one thing I just want to emphasize is I'm not saying that like it's not important for you to know anything about the machine. It's just we're not going to test you on that machine. It's not important that you know how the machine works. It's important you understand how the dot model works. That is important. That's the most important thing. So let me show you what we're going to do with the data for this one. That ticker timer puts a dot. Just think about how fast that is. It goes back and forth 60 times every second. I mean, just think about that. How fast could you wiggle your finger back and forth? Maybe 3 or 4 times per second. This thing can go back and forth 60 times per second. And every time it hits that little piece of carbon paper, puts a dot on the paper. So since each of the dots represents 1/60th of a second, what I want to do is I want to skip some dots. I don't want to look at every dot. That's going to take forever. This piece of paper had probably 150 dots on it. I don't want to look at everything. So what I'm going to do is I'm going to collect the dots together. You know, also 1/60th of a second, that's a very inconvenient unit of measure to use. So I'm going to do something a little bit different. I'm not going to count every dot. I'm going to count every 6 dots. And I'm doing that on purpose because by skipping and going to the 6th dot, now I will be at 1/10 of a second. So 6 divided by 60, put in your calculator. Your calculator is going to say 0.1. So that will be more convenient. We will count every 6 dots. I will. I already did it. I did it for you. You're not going to be asked to do it at all. I will count every 6 dot, and I will put a marker on there and say, here's the time now. And this is what it's going to look like. So if you look at that tape, you saw at the beginning how the dots are really close, and then they got more widely spaced. So what I did was I took the first about foot of that piece of paper, and I just ripped it off and threw it away because that had the acceleration part. and I wanted to be in the part where the velocity was constant. So I wanted to get rid of that acceleration part, and I also got rid of the part at the end. I want the part in the middle of the table. When the car was in the middle of the table, that's when it should have been traveling with a constant velocity. And so now what I'm going to do is I'm going to count every 6 dots, and I'm going to place a time marker on the actual piece of paper. Look, this is the actual piece of paper. Okay, so now I'm going to count every 6 dots. Here we go. Starting from the 0. 1, 2, 3, 4, 5, 6. 0.1 seconds. I'm going to count another 6 dots. 1, 2, 3, 4, 5, 6. 0.2 seconds. 1, 2, 3, 4, 5, 6. 0.3 seconds. And we will go all the way up to 0.6. Okay, so I'm going to pause right here for you guys to start filling in your data table. So your data table is going to start at a time of 0.0, and then the next one will be 0.1, and then 0.2, and then 0.3. So in your data table, can you go to your data table right now? And I'm really expecting that when I go look at this work in about maybe 10 minutes or so, that I'm going to see that you have the headings are there, and you've written the times in there. So while I'm getting the next video loaded, can you please fill in those times? 0.0 first, and then 0.1, and on down the line, all the way up to 0.6 seconds. So we're going to make 6 measurements, and I'm going to show you while I get the video loaded. You can be finishing that portion, so then you'll be all caught up.
0.0 until it reaches to 0.6, right?
0.6, yeah.
So will we calculate the displacement?
Yeah, we're just going to fill in displacement today. That's the only one. We'll do the other one tomorrow. We'll have plenty of time tomorrow to work on it. So it seems like people were having trouble seeing. Were a lot of people having trouble, or was it just a small number of people? Because we're actually going to make measurements from the video now, so it's going to be really imperative that you actually can see the video. Let me load the video, and then you guys tell me if you're able to see it or not. So just give me a second to get to it. So now we're going on to the third video, and I'm not going to play the video, the audio from the video. All you need to do is be able to see the video. Let me share, and you tell me if you can see it. I am so
last time.
Yeah, it may have just been a glitch on that last one, but hopefully it's going to show up now. I don't have my other computer on right now, so I can't see what it looks like when it's being presented. Can you guys see it says 3 data collection for DT graph?
Yes.
That's the video. Okay, I'm just going to show you what it looked like when I actually collected the data, so you can just see like how the car was connected to it. I'm going to leave the volume off, so we don't need to hear me talking in there. I can just explain to you right here, and I'll be skipping the video forward. So once we see how the data was collected, I'm just going to skip ahead to the part where I have the piece of paper on the table and I have a ruler up against it. I'm going to ask you to read the ruler from your screen right now. So let's watch how the data was collected. Let me skip ahead here just a little bit. So you'll see on the table, I have the ticker timer sitting there. The car is taped to the underside, so it's nice and secure. And that piece of paper is going on through the guides, under the carbon paper. And as it pulls, that little metal arm is going to come and hit and make little dots on that guide. Let's skip ahead a little bit until I turned it on. All right, here we go. All right, so you can see in the middle of the table, that's when the car was unobstructed. There was nothing there. That should have been good data. It should have been, supposedly, traveling with a constant velocity, but that's what we're going to find out for sure. So let's skip ahead here a little bit. You'll see that I'm going through the part where I'm marking the times. So there is 0. Right, so I'm skipping ahead through the video. Let's keep skipping ahead. Some of the dots were a little tough to see. I'm taping down the paper because that makes it a lot easier to make the measurements from. The paper doesn't get all coiled up, so I don't have to fight with it so much. And I'm going to put the ruler in there and just wait 1 second. In just a moment, I'm going to pull this back and the camera's going to get in place and we're going to be able to see this really clearly. Okay, let me back it up just a pinch. I don't like this. I'm just trying to find where the marker is going to be in the middle. That's what I'm trying to. Oh, there you go. Perfect. Okay. So right now I have the ruler lined up. If you look at the 0 on this side is lined up, and I feel like in your view, it might not look like the 0 centimeter mark is lined up with the 0 second mark, but just realize there's a little bit of an issue with perspective from the camera. So the middle of the camera is where the perspective is right, like you're looking straight down on it. But when you look on the side of the image, it's actually at a slightly different perspective. So it might not look like it's lined up, but I assure you that I was standing on the other side of the table. I was lined up. I mean, I was really careful to make sure it's lined up. So what we're going to do right now is make the first measurement. This is 0.10 seconds. I'm sorry that S looks so terrible. The person videotaping was like literally almost on my shoulder. So I'm like trying to write from the side. It was kind of difficult to do. So I'm going to read the first number for you. In this case, I put a pen mark on the dot because I thought it might not be easy to see from the video. I wish I hadn't done that because you can see the dots pretty clearly. But look, this is 3 point and it's before the 3.1. I'm saying that that little black mark is slightly before the 3.1. So let me get rid of this. I'm going to go to my data table and I'm going to fill in the first two numbers. I'll work with you to give you the first two numbers. But listen, if you don't agree with me, you can change your number slightly. You think it's 3.09 or 3.07, that's great. That's your interpretation. You should do that. So it's 0.00 at 0 seconds. At 0.10, it is at 3.0. I'm saying 3.08, but if you feel it's a little different, then do it. You should do that. Have some confidence that that's right. Okay, anybody have any questions about that before we move on to 0.2 seconds? Everybody's got that number recorded. If you don't have your data table ready, just start writing it on a piece of paper. Just put the times and write it on a piece of paper. So next, we're supposed to be doing 0.2. All right, here we go. Let me move the video forward. I talked a lot here. Okay, perfect. Now, I'm sorry that dot is so big. I wish I wouldn't have put my marker on there, my pen on there, because I think the dot was actually visible. But you can see some of the dots are a little on the faint side. Here's one over to the left that's pretty faint. You're aiming for the middle of the dot. So look, here's 6.1, or 6.0, sorry, 6.0, 6.1, 6.2, 6.3, 6.4, but it's not to 6.5. So I feel like that's pretty close to the middle, but maybe, I don't know, maybe it's just a pinch to the right. So I'm going to say 6.46. But if you see that as 4.67, 65, 64, any one of those things will be fine. It's a judgment call. But you should be recording 2 places after the decimal because that's how this ruler works. It can do it. If you take the time to estimate that last digit, it can give you that last digit. Again, everyone's clear that the assignment is not going to be due until Friday, that inattention activity. So don't sweat about it. You don't need to work on it. It's not a homework assignment. We'll do it in class. I moved it back a little bit to make space for this lab. So now we're going to move forward. Now, in the next 4 measurements, I'm not going to tell you what they are. I'm asking you to record them. Make sure you're recording them to the same level of precision as you measured this one. So let me get the 0.3 lined up for you. I'm going to try and get it right in the middle of the screen so there won't be this issue with the perspective. All right, I'm going to play it. I'm going to try and stop it when it's right in the middle. Oh, it's pretty good. Oh, that's terrible. I'm sorry. Let me fix that again. All right, here we go. I'm going to back it up just a little bit. I'm going to try to pause it when it's right in the middle. It's pretty close. It's slightly to the right of the middle, but I would say it's pretty close to the middle. All right, so I leave it up to you guys. It's your turn to decide. I will tell you this. The first digit is a 9. Okay, but you are going to read the next 2 digits. You're going to read the next digit and estimate the last. So what do you think? Remember, you're always aiming for the middle of the dot. Wherever the middle of the dot is, that's what you're looking for. Let me give you about 30 seconds. Everyone take your time, read that, record it at the 0.3 position, and then we'll move on to 0.4. All right, here we go. We're going to 0.4. I'm going to go pretty quickly through these now, because now hopefully you have a good sense of how these work. All right. On this one, I know, I'm sorry I put that pen mark there. I wish I hadn't done it, but the dot is right here on the bottom of it. So this is 13 something. 13 point and give me the next two digits. Read the next one, estimate the last one. It'll take about 20 seconds here to finish this one. That's going to be going here in 0.4. 0.4 in your table. While you're making your measurements, let me just point out, I will be releasing your quiz scores. So the velocity quiz I'll be releasing to you. Please look it over, look at the comments. That's what you should work on tonight. Let's look at our quiz. Let's think about what we're going to do on the next assessment. Do we need to do a retake, or did I pass? I'm going to move on to the next level. If you're passing on to the next level, look at the next worksheet. Look at that next worksheet. It's going to show you examples of all the problems that you have to do. All right, guys, moving on to 0.5. That's pretty decent. So look, this is 16 something. 16 point and give me the next two digits. Here's your dot right there. I'm going to move my mouse out of the way. So it's that dot just directly under that line for 0.5. And the last measurement then is at 0.6. Perfect. Now, I'm sorry I made that pencil mark there, but this is what I would say. I put this pencil mark that's on the right side. The left side is the actual dot. That's the dot right there. So if you look where the tip of my cursor is, I am pointing right at the actual dot that the machine made. That's the one you want to record. So look, it's really close to 20, but it's not 20. It's definitely less than 20. So you estimate what you feel is the value of that dot right there. It's 19 point, and give me two more digits. Okay, tomorrow we'll go over this. We'll start making the graph right at the beginning. I'll show you how to make the graph. I'll watch while you guys make the graph. So if you have any problems or questions, I'll be there to kind of help you out. We're going to learn to make graphs and tables the same way you learn to use your phone. We're just going to push buttons and play around with it until we figure it out. And the more we practice it, it'll get second nature. You won't need to ask me questions anymore. You'll just know how to do it, and you'll be able to make these really professional data tables and really professional graphs. But for tonight, you can put this on the back burner, and you're working on what level are you at? What things can you study at this level that are going to help you move on to that next level? So that's it for today. I'm going to let you guys go just a couple minutes early.